Welcome, welcome, welcome. Today we're going to be going through the Unit 1 Paper 2 from 2008. Because you know these long time paper, there's a lot of more challenging question, and so we're going to be going through these harder papers to prepare for CAPE. It's really important to do these harder papers. So the first one tells us that this is question 1, section A, module 1. The roots of a cubic equation are x. The roots of the cubic equation x cubed plus 3bx squared plus qx plus r equals 0 are 1, -1, and 3. Find the values of p, q, and r. So let's write down the cubic. So question 1, then give with that the cubic is x cubed plus 3px squared then them say plus qx plus r equals 0. Nice. And they gave us the three roots, and the three roots are 1, -1, and 3. So let's write that down. And the three roots are 1, -1, and 3. Now there are many ways to find p, q, and r. Method 1 is using sum and products of roots. Remember that the sum of the three roots is minus b over a. That's how you find sum of the three roots. And so what that means is from this, it would be minus 3p. That's the coefficient of b over a of 1. So minus 3p would be equal to, see it here, the sum of the three roots then would be 1 plus -1 plus 3. Yeah, man, it's that easy. And so we end up get minus 3p would be equal to 1 plus -1 gone equal 3. And so that means p equal to -1. So now we'll find p already. Yeah, man, we'll find p. The next thing we can do now, which is product by 2, which is the product of the sum of the roots. The product of the sum of the roots is c over a. C over a. And so that is equal to q over 1. And q over 1 is equal to product of the sum. It's going to be 1 times -1 plus, this is going to be 1 times 3 plus 3 times -1. So when we work this out, what we're going to get is q is equal to 1 times -1 is -1, 1 times 3 is 3, and 3 times -1 is -3, and so q also equal to -1. Oh, so nice, man. Q also equal to what? -1. Beautiful. Nice. Finally, we stay so now, and we're going to work out now the value of r. Now remember that the product of the three roots is given by minus d over a, and minus d over a in this case is going to be equal to minus r over 1. Now minus r over 1 is going to equal to the product of these three roots, which is 1 times -1 times 3. Yep. And so when we work this out, what we end up get is -3 is equal to minus r, and so r equal 3. minus d over a is equal to -3, so r is equal to 3. All right, nice. So that is that. So now we can actually tell them the values. So therefore, p equal to -1, q equal to -1, and r is actually equal to 3. Nice. That is what we have right there. Yeah, man, that's it. Nice, easy. This is your answer. Soft. All right, nice. All right, so let's continue right now. All right, so that was that. The next part now is to prove this right here. It says, without using calculator, show that √6 plus √2 over √6 minus √2 is 2 plus √3. All right, so that's what we're going to do. So we did the first part, remember, and we got p equal to -1. We got q equal to -1. And we also got r equal to 3. And now we're going to do this part now, which is Surds, easy. So let's do that for part 2 now. So for part 2, we have the root of 6 plus the root of 2, and that is being divided by √6 minus √2. Now, what do we know to do? Whenever you have any form of surds, what's the first thing you need to do? Rationalize. Always remember, the first thing we shall do is rationalize. So we're going to multiply by the conjugate of the denominator. So we multiply by √6 plus √2 over √6 plus √2. Yeah, man, we have to multiply by the conjugate of the denominator. Yes, yes, yes. By multiplying by the conjugate of the denominator, then what this is going to work out to be now is multiplying across their numerator. You can see that it's going to become √6 times √6, which is 6, plus √6 times √2, which is actually the root of 12. Maybe not, it's not so evident. √6 times √2, if you want to write it like this, it's √6 times the root of 2. Then we multiply √2 times √6, which is plus √6 times the root of 2. Then we multiply √2 times √2, that is just plus 2. And this is then being divided by, in the denominator becomes the difference of 2 squared. This becomes the difference of 2 squared. So it's going to become 6 minus 2. Yep. And so what this works out to be is 6 plus 2 is, what is 6 plus 2? That's 8. And then this right here, √6 times √2 is 12. So this becomes plus, this is √12 and another √12, that's 2 √12. So we have 2 √12 over 6 minus 2, which is 4. We can then go further and break up this now, because this is now 2 √12, we're going to get 8 plus, remember √12 can be broken up as, this is now 2 times √4 times the root of 3 over 4. Yeah, and then now we can write this now as, this √4 is 2, so it ends up become 8 plus 2 times 2 is 4. So that becomes 4 √3 over 4. Yep. And then now, finally, you can factor out of 4. Factor out of 4, and you're left back with 2 plus √3 in the numerator. And then this is being divided by 4. And so these 4s now cancel. This 4 cancel this 4. So you end up get 2 plus √3 for your answer. Nice and easy and soft. Nice. So proven. Put our box. Soft. Nice. All right, so let's look at this now. The next part says the root of 6 plus the root of 2 over the root of 6 minus the root of 2 plus the root of 6 minus the root of 2 over the root of 6 plus the root of 2. Show that is equal to 4. They're giving us another 5 mark to do this. They're giving away marks. It's a grab bag. So to do this one now, all right, this is the next part of it. Look how I'm going to write down this question. This question that gives you the root of 6 plus the root of 2 over the root of 6 minus the root of 2. Then you have plus the root of 6 minus the root of 2 over the root of 6 plus the root of 2. Now look what I'm going to do to simplify this now. Before I even go ahead and rationalize this and rationalize this, I already know that root 6 plus root 2 over root 6 minus root 2 is 2 plus root 3. So I already know that this part right here from around there is 2 plus root 3. This is 2 plus root 3 from the previous part of the question. So if this is 2 plus root 3, can't I see that this expression right here is 1 over this? So I can rewrite this expression here as 1 over 2 plus root 3. Tell me if you want to see that. Yeah, man, this have to be 1 over 2 plus root 3. Because remember, if this right here is 2 plus root 3, then 1 over all of this would become root 6 minus root 2 over this right here. But we'll flip it. So yeah, man, this is now 2 plus root 3 plus 1 over 2 plus root 3. So now we can go ahead and rationalize. Rationalizing, we are going to multiply. My apologies, I left off the root 3. We're going to multiply the numerator and the denominator by the conjugate of the denominator. And the conjugate of this denominator, 2 plus root 3, is 2 minus root 3. So we multiply by 2 minus root 3, 2 minus root 3 over 2 minus root 3. Yeah. So multiply by that. And so what we end up getting now is, remember, this is what we're multiplying, this times this. So multiplying those two first, 1 times 2 will become 2 minus 1 times minus root 3 is minus root 3 over, this becomes a difference of 2 squared. 2 squared would become 4 minus root 3 squared would become 3. And then this is being added to 2 plus root 3. Oh, this is so easy, man. This easy. Yeah. And so what we end up getting now is, remember, 4 minus 3 is 1. So end up with 2 plus root 3 plus 2 minus root 3. Yeah. And then the plus root 3 here and the minus root 3 here gone. And 2 plus 2 equal 4. So this is going to equal 4. That them the one we show soft. Too easy. Soft. Yeah, man. What nice. Soft. I really hit that. 4. Alright. So that is it. Okay. That is it. Soft. So done that. Nice. Next part of this paper says, show that the sum from 1 to n of r times r plus 1 is equal to 1 over 3n times n plus 1 times n plus 2. So we need to show that the sum from r equal 1 to n of r times r plus 1, and we need to show that this is equal to 1 over 3n times n plus 1 times n plus 2. 1 over 3n times n plus 1 times n plus 2. Nice. So this is what we need to show. So if we're going to show this now, this is nice. So first thing, we're going to start from over here. So to prove it, we'll start with our left hand side. Our left hand side is equal to the sum from r being equal to 1 to n of r times r plus 1. That's our left hand side. The first thing we need to do is expand in the r to get the sum from r equal 1 to n of r times r, which is r squared, plus this is then going to be the sum from r equal 1 to n of r. Cool. Nice. So good so far. So this is the sum from 1 to n of r squared plus the sum from 1 to n of r. So what this is going to work out to be is, remember that the sum from 1 to n of r squared is 1 over 6n times n plus 1 times 2n plus 1. You have to remember the formula then. 1 over 6n times n plus 1 times 2n plus 1. And then the sum from 1 to r, 1 to n of r, this part right here, so now this sum is a half n times n plus 1. A half n times n plus 1. These will be on the formula sheet. Now, what we need to do now is to add these two things. Now, I'm not very good adding so easy. So what I'm going to do is, you see this half right here, so I'm going to rewrite it to 3 over 6. Since I rewrite it to 3 over 6, this will become, first thing I realize is that I can factor out what they have in common. They have a 1 over 6, an n and an n plus 1 in common. So I'm going to factor out 1 over 6 n times n plus 1. I'm going to factorize out this. And then what I'm left back with on the inside would be the 2n plus 1 right here. 2n plus 1 right there. Plus, when I factor out 1 over 6 from 3 over 6, I'm left back with 3. So inside here, I'm left back with 2n plus 1 plus 3. So this is going to work out to be 1 over 6n times n plus 1 times, in brackets in here, 2n plus 4. But you see this 2n plus 4 right here, so I'm going to factor out a 2. This will then become 1 over 6n times n plus 1 times, you see that 2n plus 4? I'm going to factor out the 2 to write it as 2 times, in bracket, n plus 2. Now remember, multiplication is associative. Look at this. If I were to write 2 times 3 times 6, 2 times 3 times 6, that is the same as me saying 2 times 6. 2 times 6 times 3. Yeah, because multiplication is associative. So what does that mean? That means you see that 2 here, so this 2 right here, so I'm going to factor out this 2 and put the 2 out here. So I'm going to factor out the 2 out there and write it as 2 over 6 n times n plus 1. And so now I'm just left back with a n plus 2. And so then now, this 2 over 6 now, 2 into itself 1, 2 into 6, 3. So get the answer. 1 over 3 n times n plus 1 times n plus 2. Nice and easy and soft. So see there, soft. We get our right hand side, which is equal to our right hand side. So this never have nothing at all to it. That is so easy. So that's that right there. Then it says, hence or otherwise evaluate the sum from 31 to 50 of r times r plus 1. Hence or otherwise. Otherwise mean you can do it next way. Hence mean using the formula. So hence, we want to evaluate the sum from r equal 1 from 31 to 50 of r times r plus 1. To evaluate this sum, all you need to do is remember you only can apply the formula when you're summing from 1 to any number. So the sum from 31 to 50, that must be equal to the sum from 1 to 50 of r times r plus 1, yeah? Then it is minus the sum from 1 to 30, minus the sum from 1 to 30 of r times r plus 1. It have to make sense. Think about it. Think about it. What if I were to ask you what is 6 plus 7 plus 8? Check this out. 6 plus 7 plus 8. I could have tell you say it's the sum from 1 to 8, meaning I can add up 1 plus 2 plus 3. Add up 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 5. Close that. So if you were to sum up from 1 to 8, and then you were to take away from 1 to 5, I guarantee you'd get the same thing. You get what I say? Yeah, man, look at this. I'm telling you that 6 plus 7 plus 8 is equal to the sum from 1 to 8 minus the first 5. And that would have given from 6 to 8 adding. So the same way the sum from 31 to 50 is the sum from 1 to the total of 50 minus the sum from 1 to 30, which is just 1 before the 31. Yeah? So that would give you the sum from 31 to 50. So now we can delete this. Close that. Good. So let's just do this now. So now the sum from 1 to 50 is going to be equal to, remember the formula was 1 over 3n. N is now 50 in this case. In this case, n equals 50. So it's the sum from 1 to 3 of 50. That's n times n plus 1, which is 51, times n plus 2, which is 52. Close that. Minus the sum from 1 to 30, which is going to be 1 over 3n, which is 30, times n plus 1, which is 31, times n plus 2, which is 32. Yeah, man, this is what we get. So go ahead and check our stack and work this out. So I'm going to just plug this in the calculator. You see it here now. The calculator, 1 over 3n of 50 times n plus 1 of 51 times n plus 2 of 52. Close that bracket, minus 1 over 3 of n, which is 30, times n plus 1 of 31, times n plus 2 of 32. And I get 34,280. So this happened to work out to be 34,000. This is equal to 34,280. That's your answer. Nice and easy and soft. This gives you 3 marks. Question 1 done. We're done with question 1. Yeah, man. Nice. So that takes care of question 1. And so now we're moving right along to question 2. Question 2 says, the roots of the quadratic equation is alpha and beta. You have a quadratic given by 2x squared plus 4x plus 5 equals 0. So come write that down. 2x squared plus 4x, 2x squared plus 4x plus 5. And this, my friends, is equal to 0. All right, nice. And so what they tell us is that the roots are alpha and beta. So write down alpha plus beta. So number 1, oh, by the way, I have to put that roots are alpha and beta. So if the roots are alpha and beta, then that means that alpha plus beta which we know is equal to minus b over a, is minus 4 over 2, and minus 4 over 2 minus b over a, that's negative 2. Then the next thing we know is that alpha times beta is going to be equal to c over a, which is going to be 5 over 2. All right, so we write down alpha plus beta and alpha beta. So yeah, you can even put it on the paper. See it here, alpha plus beta, this part was negative 2. Alpha beta, this part was 5 over 2. All right, so we get 2 marks already. Now it wants alpha squared plus beta squared. Now alpha squared plus beta squared is given by one easy formula you need to remember. You have to remember alpha squared plus beta squared is equal to alpha plus beta all square. Saying it slow, so remember alpha plus beta all square minus 2 alpha beta. You have to remember this formula. And so this works out to be alpha plus beta all square, that's negative 2 all square. Then we minus 2 alpha beta, which is minus 2 times 5 over 2. Nice. All right. And so what this works out to be is minus 2 squared is 4. This 2 would cancel this 2, so you'd get minus, this 2 cancel this 2, you get minus 5. 4 minus 5 is negative 1. Yeah, that's negative 1. Make sure so I'm not telling you any lie. That's 4. This 2 cancel this 2, it's 4 minus 5. Yeah, that's negative 1. All right, because I don't want to be lying. That's negative 1. So here, so this works out to be negative 1. Now it says find alpha cube plus beta cube. That's easy. So let's do it over here. Let's change the ink for this one. Let's go to a black ink. So for part 3 now, we want to work out alpha cube plus beta cube. Alpha cube plus beta cube. Now alpha cube plus beta cube is given by the formula alpha plus beta all cube. Remember this formula now, it's alpha plus beta all cube minus 3 alpha beta times alpha plus beta. Yeah, that's what it is. Alpha cube plus beta cube is alpha plus beta all cube minus 3 alpha beta times alpha plus beta. So alpha plus beta was minus 2. So we have minus 2 cube. Yeah. Then we want minus 3 times alpha beta. Alpha beta is 5 over 2 times alpha plus beta. And alpha plus beta again is minus 2. Now the thing is, I really can't, maybe I can, but I'm just going to use my calculator. All right, so bear with me. Not that sharp. So I'm going to have to use my calculator. So it's minus 2 cube, that's alpha plus beta, minus 3 alpha beta. Alpha beta is 5 over 2, close that bracket, times alpha plus beta, which is minus 2. It's sad that I have to use my calculator for this, but that's 7. All right, I know it's really sad. It's really sad. Yes, it's sad. I had to use my calculator. That's 7. All right, so we can write that down now. So this equals 7. So now it says find a quadratic whose roots are alpha cube and beta cube. So to find that quadratic whose roots are alpha cube and beta cube, so we need a new quadratic equation. So I like to write new QE, my new quadratic equation. My new quadratic equation, remember, it's going to be x squared minus the sum of the roots times x plus the product of the roots. That's the equals 0. That's a new quadratic equation formula. So now the sum is alpha cube plus beta cube. The sum is alpha cube plus beta cube. Alpha cube plus beta cube. But already know, so that equals 7. Yeah, man, that's 7. Now we need the product. The product is equal to alpha cube times beta cube. But alpha cube times beta cube is actually equal to alpha times beta all cube. This is alpha times beta all cube. So this would work out to be equal to alpha times beta. Alpha times beta, where are you? That's 5 over 2. So we have 5 over 2 being all cubed. And so when we work that out, that would be now 5 cubed is 125 over 2 cubed is 8. So now what is our new quadratic equation? Our new quadratic equation is x squared minus the sum of the roots, which is minus 7x, plus the product, which is plus 125 over 8, equals 0. Equals 0. That's our new quadratic equation. So finish, we're done, we're nice, we're not nothing to worry about. See it there? Yeah, man, we that. This is we. Yep. So let's write it down around here. If you want, the new quadratic equation is x squared minus the sum of the roots 7 times x plus the product of the roots, which is 125 over 8, and this is equal to 0. That's the quadratic equation with roots alpha cube and beta cube. All right, next part. It says, this is a little blurry, but it says solve for x in the equation x to the 1/3 minus 4x to the minus 1/3 equal to 3. X to the 1/3 minus 4x to the minus 1/3 equal 3. Go do it around here. So we have x to the 1/3 minus 4x to the minus 1/3, and this is equal to 3. Yeah, that equal 3. So to work this out now, what we can do first is multiply through by x to the 1/3. Yeah, man, multiply through by x to the 1/3. When you multiply through by x to the 1/3, this will become x to the 1/3 all square, x to the 1/3 square, then x to the 1/3 times x to the minus 1/3. Always remember a times a inverse is 1, so that becomes minus 4 equal to 3 times x to the 1/3. Yeah, man, this becomes 3 times x to the 1/3. So bring that over here now to get x to the 1/3 all square. Then you have minus 3 times x to the 1/3. And then you have minus 4 is equal to 0. All right. If this make you feel better, you can actually call x to the 1/3 y. All right. If it lets you feel better, let x to the 1/3 be equal to y. I could have done it from the start. Let x to the 1/3 equal, I'm not going to use y, y is too common, let it equal m. So this would have just become m squared minus 3m minus 4 equals 0. So now time to what? Yes, factorize. So now we would factorize, and what we're going to get is, this is now m, this is now 4 and 1. Signs are different. The greater product is negative, so this is minus and this is plus. So that means that m equal minus 1, and this means that m equal 4. If m equal to minus 1, let's finish it over here. Remember, m was x to the 1/3. So that means x to the 1/3 and x to the 1/3 can be written as the cube root of x. So the cube root of x equal minus 1, or the cube root of x equal to 4. So if the cube root of x equal minus 1, you can cube both sides. And so x would be equal to minus 1 cube, and minus 1 cube is just minus 1, because we cube both sides to get that. Or over here, so when you cube both sides, you get x is equal to 4 cube, and 4 cube is 64. So this will tell us that x equal 64. So x equal minus 1 or x equals 64. Nice and easy and soft. Yeah, man. So x equal minus 1 or x equals 64. So this is right here. We end up get, so for the first part, we get x can equal to negative 1 or x equals 64. All right, now the next part. The next part says find x such that the log to base 5 of x plus 3, is this 5? I think this is a 5, all right? Yes, this paper is really blurry, and my apologies. I don't know why it is this blurry. This is log to base 5 of x plus 3 plus log to base 5 of x something. So the next part says log to base 5 of x plus 3 plus, this is log to base 5 of x minus 1. And they're telling me that this is equal to 1. Beautiful. So first thing I need to write this as 1 logarithm, which is log to base 5 of, in bracket, this is going to be x plus 3 times x minus 1. That's what we're going to get, x plus 3 times x minus 1, and that is equal to 1. So remember then, the definition of logarithm is base to the power equal to the number. So that means that 5 to the 1 is equal to x plus 3 times x minus 1. Yeah, man, that's all. And they end up with one quadratic to solve it. That easy. 5 to the 1 is 5. So 5 is equal to x times x is x squared. X times minus 1 is minus x. 3 times x is 3x. 3 times minus 1 is minus 3. So what we end up get is this work out to be x squared. You can bring over the 5 now and make everything equal 0. So minus x plus 3x is, that's plus 2x. Bring over this 5, it becomes minus 8. So now we can factorize it. Nice. Factorizing it. So we're going to end up just write x, x. This right here, so signs are different, greater product positive. So when we have 4 and 2, but the bigger one positive, so we'll put a plus and we'll put a minus, and this equals 0. All right, so just to check back, x squared, 4x minus 2x minus 8, good. So end up get x can equal 2 or x can equal to negative 4. Then there are two possibilities, x can equal 2 or x can equal to negative 4. And we're done. We're nice. Okay, this was so easy. It was easy, so tell it boring. Right? So x can equal 2 or x can equal, I think, negative 4. But let's look at something. Oh, I'm so stupid. Well, not really. My apologies. X cannot equal to negative 4 because we can't take the log of a negative number. The only possibility is x equal to. All right, so this one I should have said is not possible. This part here is not valid. Not valid because we cannot find the log of a negative number. We cannot find the log of a negative number. Neg mean negative. All right, so the only answer is this one. This is the answer, x equal 2. It's when I went back on the question, I quickly noticed that, but wait, if I were to put in minus 4 up here, that would be negative, but we can't find the log of a negative number. So just to verify it, with you, what I'm going to do is I'm going to show you it on my calculator. Right, look at this. If I were to write the log of, base 5 of x plus 3 and put x as 2, look at that, 2 plus 3 plus log to base 5 of, this is now 2 minus 1. I guarantee I'm going to get the 1. See there, I get the 1. That's because x equals 2, but minus 4 couldn't work. Minus 4 cannot work. So x equals 2 is the only value for x. Check out part 3 now. Without using your calculators, which we already have, or tables, evaluate this. So let us evaluate this now. So I want to evaluate the log to base 10 of 1 over 2, log to base 10 of 1 over 2, plus log to base 10 of 2 over 3, plus, I guess the next one is going to be log to base 10 of 3 over 4, log to base 10 of 3 over 4, and this is going to continue all the way up to, is that 9 over 10? Yes, it is, plus 9 over 10. So this is easy, 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 right? Very easy, plus all the way up to log to base 10 of 9 over 10. Now, this is very easy. Let us quickly evaluate this logarithm. This has nothing. This is nothing. So to do this now, what we need to do is write this as one logarithm. The log a plus log b is a log of a times b. So writing this as one logarithm is end up going to be 1 over 2 times 2 over 3 times 3 over 4 times 4 over 5 times, I'm going to keep on to that till we have times 8 over 9 times 9 over 10. Okay, no problem. So then guess what happened? This 2 right here cancels this 2. This 3 right here cancels this 3. This 4 right here cancel the 4 decimal. This 8 cancel the 8 somewhere down there. So this 9 cancel the 9 right here. So this works out to be equal to the log to base 10 of, this is 1 over 10. That's your answer. But you could quickly realize that this is just log to base 10 of 1 over 10 is 10 to the minus 1. And then by rules of logarithm, we can carry down the power minus 1 of log to base 10 of 10. But log to base 10 of 10 is negative 1. This is negative 1. So that's the answer, minus 1. Easy, soft, nice. This is just minus 1. All right, so end up get minus 1. Yeah, man. It's just minus 1. All right, and if you were to actually do it in a calculator, the log of a half plus, well, I can't bother to write out all of that. Check it another time. Just write down the answer right here. We get that this equal to negative 1. All of this equal to negative 1. All right, so we're done module 1. So module 1 was no challenge at all.